refrigerant charge for air conditioners and heat pumps. The references for these tests is going to be the reference appendices section RA 3.2, again found at the particular link on the CEC website or also available for download on the LMS system.
The refrigerant charge test is designed to verify that the HVAC system was properly charged and to identify any potential refrigeration system faults. Now, prior to performing the procedures that are described in this training, you must first obtain your EPA 608 Type 2 certification. Now, these can be obtained at any HVAC supply house. You simply go in and let them know that you need to get your EPA 608 certification, and they will walk you through the steps for obtaining that. Usually it's purchasing a training manual as well as the exam, which you will first study for, and then you'll go in, you'll take your proctored exam at that location, and once you pass, they will issue your 608 certification.
Our overall goal is to familiarize yourself with refrigerant charge testing equipment, protocols, and forms. These are the sections that we'll be covering this PowerPoint. So starting with equipment specifications, just like we covered in all the other sections, we're going to be talking about what equipment is required and allowed for these tests. When taking a temperature measurement shall be made utilizing digital temperature measurement instrumentation that is combined sensor plus device for data acquisition, processing, and reporting that shall have dual channel capability in Celsius or Fahrenheit and conform to the following specifications: an accuracy of plus or minus 2 degrees and a resolution of 0.2 degrees. When using a hygrometer, the hygrometer shall have a probe of at least 3 inches in length. It shall be able to take both dry and wet bulb measurements. It will have an accuracy of plus or minus 2 degrees Fahrenheit wet bulb temperature, or calculated wet bulb temperature based on accuracies of plus or minus 3% RH and plus or minus 2 degrees Fahrenheit dry bulb temperature, and a resolution of 0.2 degrees. When taking pipe temperature measurements, they shall be taken when taking temperature measurements of sectional or liquid refrigerant lines using sensor mounting styles such as a pipe clamp sensor, Velcro strap-on, or an equivalent sensor device or sensor mounting method shall meet the following specifications. Again, an accuracy of plus or minus 2 degrees and a resolution of 0.2 degrees. For temperature sensor response time specifications, all previously described sensors shall produce an accurate reading within 90 seconds of insertion into the test environment. The refrigerant gauges, they shall be digital and they shall meet the following specifications: the liquid line pressure accuracy of plus or minus 7 psi and a section line pressure accuracy of plus or minus 3.5 psi.
As an alternative to the use of refrigerant gauges, 2 saturation pressure measurement sensors, or SPMS, may be permanently installed by either the equipment manufacturer or in the field by the installing contractor in a manner and location approved by the equipment manufacturer for use to measure the saturation pressure of the refrigerant in the evaporator coil and in the condenser coil. So again, these can either come from the factory pre-installed, or the installing contractor can install them in the field in the locations approved by the manufacturer. Now these pressure measurement instrumentation shall have an accuracy equal to or better than plus or minus 7 psi for the liquid line pressure and plus or minus 3.5 psi for suction pressure.
When using a refrigerant scale, the refrigerant scale shall be electronic and it shall have an accuracy equal to or better than plus or minus 5 ounces or plus or minus 5% of the measured value. Please keep in mind that as a rater, you will not be using a refrigerant scale, but rather you'll be observing an installer or an HVAC technician using the scale to potentially use the weigh-in method for refrigerant testing. We're going to be talking about the different ways to test for refrigerant charge, but in this particular case, the condenser outlet air restrictor is used specifically for the winter setup procedure and only for the winter setup procedure. It's a device that restricts the free area of the outlet from the condenser fan to reduce the airflow, but does not interfere with the air entering the condenser coil. The amount of restriction shall be adjustable. So this particular hood that you can see in the picture here will be used for the winter setup procedures, which we'll be talking about later on in this PowerPoint. For calibration, all temperature sensors except hygrometers and refrigerant gauges shall be calibrated monthly in accordance with specification in section RA 3.2.2.4. A sticker with the calibration check date shall be affixed to each instrument calibrated. The way that you're going to go about calibrating each piece of equipment is going to be dependent on the manufacturer. So follow your manufacturer's instructions and specifications in order to calibrate your equipment correctly. Hygrometers shall be calibrated according to the manufacturer recommended time, intervals, and procedures. A sticker with the calibration check date shall be affixed to each instrument calibrated. Refrigerant scale should also be calibrated according to the manufacturer's recommended time, intervals, and procedures. A sticker with the calibration check date shall be affixed to each instrument calibrated. And now we'll be covering the actual testing procedures.
While refrigerant charge is prescriptively required in climate zones 2 and 8 through 15, and may also be required if it is taken outside of those climate zones on the performance method, there are several situations in which the refrigerant charge does not apply. For example, the first one here, the system does not have air conditioning installed. If there is no AC system that uses refrigerant, there's no way to do that refrigerant charge, and so it will be removed as a required test. The next one is if the system is a new package unit and it has been factory charged, so it will be certified to be properly charged from the factory, and this will be indicated in the documents. So the installing contractor will need to provide the make and model and AHRI certification number. However, there is no verification for the HERS rater. There is no 3R form that will be generated because there is nothing for you to do. It's already been certified at the factory. However, the minimum airflow will still need to be verified for this system. So airflows will still be triggered. And then finally, as we'll talk about in the next module, which is HVAC components and devices, there is a piece of equipment called a fault indicator display, or FID. So if the contractor has decided to install an FID, they will still have to do the refrigerant charge methods that we previously described, or that we're describing in this section. However, your verification will be slightly different, as you will only be verifying that the FID is correctly installed and is operating within the described parameters.
So when the refrigerant charge is in fact required, there are two methods to conduct the refrigerant charge verification of system. We have the standard charge verification procedure, and keep in mind that the wintertime setup procedure is a modified version of the standard verification allowed on manufacturer-approved AC equipment. We'll be talking about that procedure later on. The second method is the weigh-in charging procedure. As a HERS rater, you're not going to be conducting the actual weigh-in charging procedure, but nonetheless you'll be observing the installer conducting the charging procedures and confirming that they're conducting it properly. The standard charge verification procedure is applicable to ducted split systems air-cooled air conditioners, ducted split systems air source heat pumps, and it may be applicable to packaged air-cooled air conditioners and packaged air source heat pumps.
There are some general requirements that are going to be applicable to all of the various procedures. Under standard charge, we have what is called subcool and superheat. And the way we determine which of those two standard charge procedures to use is going to be based on the type of metering device that's installed. So we need to visually verify that the metering device, what type of metering device is installed, and then also that it's operating properly. Now this is going to be a function of the actual test itself to determine whether or not it's operating properly, but to begin with we need to identify what we're working with so that we know how to determine whether or not it's operating properly. So here to the right we have three different types of metering devices. In the upper left is our TXV, or thermostatic expansion valve. To the right is the electronic expansion valve, and at the bottom is our fixed metering device, also called a piston. What you're most commonly going to see out in the field is going to be either a TXV or a fixed metering device, and so we'll talk about each of those here for a little bit so that you have an understanding of how they work. So let's start with the very basic fixed metering device or piston. This little item is going to be found in the liquid line right at the evaporative coil. So behind this piston you have liquid at high pressure that's been compressed at the condenser, and it's making its way up to the evaporator coil, and you can see at the bottom of that picture there's a hole. So all of that refrigerant is going to be forced through that hole or orifice, and as it comes out the other side it's going to pass from a high pressure environment to a low pressure environment. The pipe on the other side is going to be larger, so there's more room for it to exist, and so it's going to be able to expand, and it's that expansion that helps us with the absorption of heat within the evaporator coil. Now these pistons will have different size orifices in them, and that's not something that you're going to be able to see or look at because it is within the system itself, but just so you know, different size coils will have different size pistons in them, and this will determine whether or not it's working properly, and we'll take a look when we do the superheat testing for this, because that's how you verify these. That'll let us know if the correct size piston is in there and if the coil is getting the airflow across it appropriately for the way it's set up. Now at the top left, let's take a look at the TXV. These are going to be found on newer systems predominantly. In order to achieve the efficiency values that we need on current equipment, it's required you have to have a TXV in order to reach those efficiencies. Older equipment is where you're going to find the fixed metering device, unless it's been retrofit and they've added in a TXV, which they can do. They pull out the piston and then they install a TXV in its place. Now a TXV is a little bit smarter. It has a sensing bulb, which is that coil of wire with that bulb off to kind of the left side of the picture there. And that's going to sense the temperature of the outgoing refrigerant. So it's going to be installed on the suction line, where the TXV itself is on the liquid line. And based on the temperature of that outgoing gas on the suction line, that TXV is going to adjust the opening or the orifice, for example on the fixed metering device. It's going to vary that and allow either more or less refrigerant to enter into the evaporator coil based on that. So you always have the perfect amount of refrigerant going through so that that coil is able to operate at its most efficient state. So that's your basic two metering devices. And a TXV is going to require a subcool verification, where a fixed metering device is going to require a superheat verification procedure. EXV falls into the same group as the TXV. It just uses an electronic means to vary that flow versus just a thermostatic means.
You will then have to verify the outside temperature. The standard charge verification procedure may only be used when the outdoor air temperature is 55 degrees or above. The return air dry bulb temperature shall be maintained above 70 degrees during the whole test. In addition to that, as we talked about during the Title 24 overview, there needs to be measurement access holes drilled into the return plenum. When return plenum measurements are necessary for compliance with refrigerant charge verification requirements, a 5/8 diameter hole shall be provided as shown. Those particular holes shall be sealed to prevent leakage after the measurements have been completed. They can be applied to any of the four sides of the return plenum, and they shall be labeled Title 24 Return Plenum Measurement Axis in at least 12-point type, just like the sample picture below. For air handling units with the return located entirely within conditioned space, the return plenum measurement axis hole is not required, and in this case, the return air temperature measurement shall be taken at the return grill. Systems that cannot conform to the measurement axis hole requirement shall be not required to have the holes as previously described. However, if return plenum measurements are required for compliance, an alternate location that provides access for making an accurate return plenum measurement shall be used. So you as a refrigerator will be able to determine whether the measurement axis holes are required or not as previously described. If for some reason the holes cannot be drilled due to the location of the system or architectural issues that impede the drilling of the holes when the system is in place, you can in fact pass the system without the holes being present. However, you do have to verify that the holes were or were not drilled for whatever reason. One of the prerequisites for the refrigerant charge is for you to verify the airflow like we described in previous sections. The procedures to verify the airflow for the refrigerant charge work the exact same way as previously described.
Compliance with the standard refrigerant charge verification procedures requires that the system meet minimum system airflow rate criteria. Now these standards of compliance do vary between new systems and altered systems, as well as we may see different values modeled using the performance approach. So our default prescriptive values for new systems can be dependent on the type of duct system. So for your traditional duct systems, it's going to be 350 CFM per ton. If you have a small duct high velocity system, it's going to be 250 CFM per ton. And then for altered systems, it's 300 CFM per ton. Now again, I mentioned on the performance side, if you're modeling performance, you can change this value from the 350 or 250. So you will need to be sure you review the CF1R to see what CFM per ton value was modeled so that you are comparing to the right value.
Now, when conducting the actual standard charge verification procedure, you want to operate the air conditioner in cooling mode for at least 15 minutes to allow the temperatures and pressures to stabilize before taking any actual measurements. So you want to turn the system on and just let it run for at least 15 minutes. While the system is stabilizing within the 15-minute period that we just talked about, you can proceed with setting up the equipment. Be sure that all cabinet panels that affect airflow rate are in place before making measurements. The temperature sensor shall remain attached to the systems until the final charge is determined. Wet bulb measurements shall be taken using distilled water.
Step 1, you will want to follow the manufacturer's directions and adhere to the manufacturer's limitations on indoor ambient air temperature and outdoor ambient air temperature that are applicable to this procedure. Now we did talk earlier about the allowed range of temperatures. It must be 70 or above on our indoor ambient and 55 or above on our outdoor ambient to perform the standard charge verification procedure. But if those manufacturers' restrictions are tighter than what the code allows, so let's say that it must be above 60 degrees outside, then you'll need to follow those manufacturers' directions. So if they are more stringent than the code, follow the manufacturer's directions. Next, you'll want to verify that a liquid line filter dryer has been installed if required by the outdoor condensing unit manufacturer's instructions, and that is installed with the proper orientation with respect to the refrigerant flow if that's applicable. So how do we know if a filter dryer is required? You will need to get the installation instructions from either the installing contractor, or oftentimes you can go online to the equipment manufacturer's websites. They'll have instructions available for download as like a PDF. So you can go in there and look and verify, and if that manufacturer does require that a filter dryer be installed, then it should be installed. So a filter dryer is essentially what its name implies. It not only is a filter, but it also is it dries the refrigerant. So moisture is an enemy within the system. Most of that moisture should be pulled out when they draw down the system to 500 microns, but any remaining moisture will be absorbed by the desiccant that's inside this container. It also has a filter to try and catch any contaminants that might be left in the system that's flowing around. So the picture here is a typical liquid line filter dryer. You can see that it does have an arrow on it, so this one does have a proper orientation that it needs to be installed. The refrigerant needs to flow in the direction of that arrow. So for a standard split AC system, that's going to be from the condensing unit to the evaporator coil. So that's the direction of the liquid flow. It gets condensed into a liquid at the condensing unit through the compressor, and then it flows towards the evaporator coil, where it then is allowed to expand into a gas. Now if it is a heat pump system, it's going to have an arrow that points in both directions, and that's because a heat pump is going to have a reversing valve on it that will allow the refrigerant to flow in either direction depending on whether it is in a cooling mode or a heating mode. So just make sure that that arrow is pointing in the right direction if it is applicable to that system.
Connect the refrigerant gauges to the surface ports using low-loss fittings, taking normal precautions to not introduce air into the system. Now, before you do this, be sure that you have obtained your EPA 608 certification. If you have not, you cannot perform this step. You will either need to have the HVAC technician there with you. He can connect your gauges to the system. You cannot use his gauges, you need to use yours. And he can assist you with performing this step and the next steps as well. If you have your EPA 608 certification, then you're good to go. You're going to want to take the hose. Generally, it's going to be a red hose on the red side of the gauges, which is our high pressure side. That's going to be connected to the liquid line. The liquid line is the smaller diameter of the two copper lines that you'll see in the top picture there, as well as on the bottom. It's the one on the left-hand side. It's not always going to be on the left-hand side, but that's where it is here. You'll unscrew that little cap, and behind it is a threaded fitting with a Schrader valve behind it. Schrader valve is like what you would see on a car tire or a bicycle tire, and so you'll screw that on there, and as you screw it on, it's going to depress that valve, and it's going to now connect the hose to that the pressure on the liquid side. Same thing on the other. The suction line is the low side. That's going to be your blue hose. Generally your blue hose, it doesn't have to be that color, but that's generally what it is, and it'll be connected to the blue side or the low side on your gauges. This is going to be the larger of the two copper lines, and again, you'll remove that cap, thread your hose onto there, depressing that Schrader valve, and that will allow the pressure on both sides to equalize.
You will then attach one pipe temperature sensor to the suction line and one to the liquid line near the service valve. The sensor should be positioned to make good contact with the surface of the refrigerant lines. Make sure they're snug on the lines and they're nice and tight.
You will need to measure and record the dry bulb temperature of the air entering the condenser. The sensor shall be placed so that it records the average condenser air entering temperature and is shaded from direct sun. So depending on where the unit is located, if it's on the shady side of the house, it's not that big of a deal. You'll just take a measurement on one or two sides of it and kind of average those out. Oftentimes it's going to be the same. You're not going to get different temperatures on there. But if you are on the sunny side of the house, you'll want to make sure that you get on the side of the condenser that is either shaded, or you may need to use your body or clipboard or something to provide shade so that the sun is not shining directly on your temperature sensor. And you'll take an average of all 3 or 4 sides of that condenser to find what the average temperature of the air is that's entering that condensing coil at the condenser itself.
Back at the unit, using the Title 24 return plenum measure axis as previously described, measure and record the return air dry bulb temperature, also labeled as T-return dry bulb.
If the system has a fixed metering device using the same return plenum access hole used in step 6, you need to measure and record the return air wet bulb temperature, and you want to make sure that when you're doing this that you do not get the dry bulb sensor wet, otherwise it will act like a wet bulb temperature sensor. So if they have a TXV or EXV installed, you do not need to complete this step. This is only when a fixed metering device is used. Now you'll see there to the right is our wet bulb sensor. It's got a little sock on the end of the thermocouple. You would get that wet with distilled water. You want to use that so you don't have any of the minerals or anything else that may be in regular tap water. This can affect the reading. So always have a bottle of distilled water with you that you can get that wet with. And you're going to insert it into the same hole, making sure that you keep a distance in between the dry bulb sensor and the wet bulb sensor.
Then you want to look at your refrigerant gauge, and using the refrigerant gauge you want to measure and record the section line, which is the low side pressure. You will then want to measure and record the section line or the low side temperature, also labeled as T section. You'll be able to grab these temperature readings directly off your gauge. Now, just like you did on the section side, using the refrigerant gauge, you want to measure and record the liquid line or the high side pressure of the system. You will then measure and record the liquid line temperature, which in this case is going to be labeled as T liquid.
The following steps will describe the calculations used to determine if the system meets the required refrigerant charge and metering device function using the measurements that you just collected. Now, if the system fails, then remedial actions must be taken by the HVAC system installer to bring these into compliance. They'll have to come out and they will have to adjust the amount of refrigerant in the system to bring it within the required values. Now, while we are going to cover the calculations, because we are using digital refrigerant gauges, most of these are going to have the ability built in to where they will provide you with the results of these calculations. You won't actually have to perform the calculation. You'll just have to press some buttons on the gauge itself to scroll to a different screen, or it may be that it's on the screen that you're already on, that it's going to provide you with the superheat or the subcool or whatever value that you are going to be shown the calculation for next. At the same time, even if your gauge doesn't do those calculations for you, but when you go into the registry to enter your results, the registry will perform those calculations. So once you enter in the values that are needed, it's going to automatically calculate those values, as well as it's going to determine the pass or fail of those results. So you don't really need to do these yourself, but we want to show you how these calculations are performed, just so you have a better understanding of the overall refrigerant charge verification.
So, the superheat charging method is going to be used for systems with fixed metering devices. If you have variable metering devices, then the subcooling charging method will be used for those type of systems. When we're talking about variable metering devices, we're talking about the thermostatic expansion valves, TXVs, or electronic expansion valves, EXVs.
To calculate the actual superheat, you will use the suction line temperature and subtract the evaporator saturation temperature.
You will then want to determine and record the target superheat using table RA 3.2-2 or the manufacturer superheat chart using the return air wet bulb temperature, which is the T return WB, and condenser air dry bulb temperature, which is the T condenser DB.
Here we have table RA 3.2-2. So the way that we use this chart is we have two items. We have our condenser air dry bulb temperature, which is going to be our rows, that's on the left hand side there, and then we have our return air wet bulb temperature, which is going to be our columns at the top. So we're going to take our dry bulb temperature that we measured out at the condenser, and we're going to find where that is on the left. So let's just say it's 70 degrees. And then we're going to take our wet bulb temperature, which we collected with our wet bulb thermocouple in the measurement access hole at the return air. And let's just say that that was 58. So if we come across, we find 70 on the left-hand side on the rows, and we find 58 in the column, and we bring those together, and we're going to see that our target superheat is going to be 12.7.
Keep in mind that if a dash mark is read from table RA 3.2-2, the target superheat is less than 5 Fahrenheit. Note that a valid refrigerant charge verification test cannot be performed under these conditions. The usual reason for a target superheat determination of less than 5 degrees Fahrenheit is that the outdoor conditions are too hot and the indoor conditions are too cool. You can do one of the following so a target superheat value can be obtained from table RA 3.2-2. You want to turn on the space heating systems and or open the windows to warm up indoor temperature, or just retest to another time when the conditions are different. You will then calculate the difference between the actual superheat, which we found in step 1, and the target superheat, which we found in step 2. So actual superheat minus target superheat. And you will then determine if the system complies. If the difference in superheat is within plus or minus 8 Fahrenheit of the specified target, the system complies and it's a pass. Now, when you actually have variable metering devices, you're going to be using the subcooling charging method. So in order to do that, you're going to calculate the actual subcooling as the condenser saturation temperature minus the liquid line temperature, and that's the formula.
Next, you'll need to determine the target subcooling that is specified by the manufacturer. So there's two main ways that you're going to do this. The primary way is you're simply going to go out to the condensing unit and look at the label, and on the label, like we can see, here's a sample label here on the right, it's going to list subcooling. Sometimes it'll say, indoor TXV subcooling or something a little bit different along those lines. Sometimes it just says subcooling, but it's going to give you a value, and that value is going to be generally pretty low in the area. You're going to see, maybe 5 to 20 degrees Fahrenheit is going to be your average range. Oftentimes it's going to be right in the middle of that. 10 to 13 or so is what we oftentimes will see. In this example here, you can see it's 7 degrees Fahrenheit, but that's where you're primarily going to find your subcooling target. Now, every now and then you're going to find a label that doesn't have that on there, so you're going to have to either get the manufacturer's literature from the installing contractor, or you're going to have to go online and look up the make and model number and get those documents and find the target subcooling within those documents.
You're going to calculate the deviation of the actual subcooling value from the target subcooling value. And the subcooling deviation is going to be the actual subcooling minus the target subcooling. You will then determine if the system complies. If the difference in subcooling is within plus or minus 6 Fahrenheit of the specified target, and the subcooling is equal to or more than 2 Fahrenheit, the system complies and it's a pass.
Now, as part of the overall subcooling charging method verification, you are going to need to calculate the actual superheat as well. Just like we did under the fixed metering devices, we calculated the superheat. We're also going to need to do that under the variable metering devices, and this is part of what tells us whether or not that TXV or EXV is working correctly. So just like before, you're going to calculate the actual superheat as the suction line temperature minus the evaporator saturation temperature.
You will then want to determine if the system complies. If possible, determine the superheat range specified by the manufacturer. If the superheat meets the manufacturer specifications, or the superheat is between 3 Fahrenheit and 26 Fahrenheit, the system complies and it's a pass. So we mentioned earlier the winter setup verification procedure, which is a modified version of the standard verification procedure. This particular modified procedure is applicable to any ducted split system, central cooled air conditioning, and duct system split system, central air source heat pumps, for which the system manufacturer has specified that this procedure may be used to verify the refrigerant charge. So the manufacturer has to specify that this modified procedure is allowed with their equipment. It can only be used for units with variable metering devices, TXVs and EXVs. So anything that has a fixed metering device, you cannot use this this modified test procedure with. And then only systems, again, approved by the manufacturer for these procedures may be used in combination with this procedure. So why use the winter setup verification procedure? You see, the standard charge measurement procedure calls for the outdoor temperature to be 55 degrees or higher. The winter charge setup creates the right conditions at the unit being tested for outdoor temperatures above 37 degrees and below 71 degrees that allow the system to operate in the same range of pressure differences between the low side pressure and the high side pressure as occurs during warm outdoor temperatures. The winter charge setup achieves an appropriate high side, low side pressure differential to conduct the standard charge verification procedure by restricting the airflow at the condenser fan outlet through the use of a condenser outlet air restrictor, which is that hood over the condenser that we showed you in pictures earlier. So you'll want to install the condenser outlet air restrictor on the outlet from the condenser fan. You want to position the restrictor so it does not interfere with the inlet airflow to the condenser. So as you can see here, the restrictor is positioned over the top of the condenser. It's blocking the top, or restricting the top, I should say, but nonetheless is not blocking the side of the condenser and the condenser coil from intaking air. You will then want to start the air conditioner or heat pump in the cooling mode and restrict the outlet until the difference between the high and low side pressure is between 160 psi and 220 psi for R410A and between 100 psi and 145 psi for R22 refrigerant. You will want to allow the unit to stabilize for 15 minutes again, watching the pressures to make sure the differential achieves and remains within the threshold described in step 2. You will then follow the test procedures previously described for the standard measurement and variable metering device calculations to determine compliance. Compliance with the winter setup verification procedure still requires the system meeting the minimum system airflow rate criteria measured again as previously explained. So all the previous requirements that we talked about do not go away or do not change for the winter setup verification procedure. Keep in mind that that particular modified procedure can only be used with systems that have a variable metering device installed, meaning a TXV or an EXV.
The weigh-in charging procedure is going to be applicable to air-cooled air conditioners, air source heat pumps, and mini splits, or oftentimes are called multi-splits as well. And this is going to be used primarily when the manufacturer states that you cannot use the standard charge procedure in order to verify that these are properly charged. The installing contractor does have the option to use the weigh-in charging procedure in certain conditions, but you as the HERS rater can only use it to verify when the manufacturer states that the standard charge procedure cannot be used.
The weigh-in charging procedures may be utilized during any outdoor temperature. And again, keep in mind that you as a HERS rater will not be conducting the actual procedure, but nonetheless you'll be observing the installer conducting the procedures and verifying that they're conducting it properly. It still requires verification of the air system airflow rate as described in previous lessons. So that requirement does not go away. You will still need to test for airflow and minimum airflow requirements.
The weigh-in charging procedure shall be used by the installing contractor when the outdoor temperature is below 55 degrees Fahrenheit and there is no applicable special case refrigerant charge verification protocol available for use. By this, they are referring to the winter charge verification protocol. That is the only special case, and not all equipment is approved for use with that winter charge procedure. When the weigh-in charge procedure is used by the installing contractor, the HERS rater may not utilize group sampling for this measure. So any homes that use the weigh-in charge procedure must be tested by the HERS rater.
There are two methods to conduct the weigh-in charging procedure: the weigh-in charge adjustment or the weigh-in total charge. Again, the installer will conduct these tests, not the HERS rater.
The charge adjustment option is applicable to a new system or existing system when a new outdoor unit is installed. So this outdoor unit, that's going to be the condenser, and these condensers come from the factory with a refrigerant charge already applied. So they will install in the unit a specific amount of refrigerant, and this is usually based on the size of the condenser. They have an estimated average line length, so for the refrigerant line, and then the expected size of the indoor coil. So this charge that's in there should be enough to handle that condensing unit, a specific length of line, as well as an indoor coil, so that the installer only has to add or remove a very small amount of refrigerant if they are within those parameters. Now, if they install a much larger or shorter length of line set, or a much larger or smaller coil, then it's going to be either too much or not enough, and it's going to be a larger adjustment that's going to have to be made. So the HVAC installer will weigh in the line set and indoor coil charge adjustment after evacuation of the line set and indoor coil. So they're going to draw a vacuum on the line set and the coil to get all of the air and moisture out of it, and then if it's outside of those parameters, they're then going to have to weigh in additional refrigerant. Now, the documentation will include the calculated charge adjustment for the line set, and that comes from the manufacturer. Depending on if you are outside of those parameters, they will say if you are outside of those parameters, but this is what you did, here's the amount of adjusted refrigerant that you're going to need to install or remove from the overall system. The total charge option is going to be applicable to all systems. So for this, the installer shall weigh in the total system charge after refrigerant recovery and evacuation of the entire system. So this is going to be either for new systems or where you're replacing just a part of the system. The installer is going to have to recover all of the refrigerant out of the system. So they're going to pump it all down and put it into a storage container so that there's no refrigerant existing in the system any longer. Now, to determine the amount that they're going to need to weigh in, they'll need to calculate the nameplate charge for the outdoor unit, and then any adjustment for the line set dimensions and indoor coil, and this is going to be in accordance with the manufacturer's instructions. So they're going to go back to the manufacturer, and it's going to say you need this much for the condenser, this much for your line set, and then this much for your indoor coil. And then the installing contractor is going to need to document all of this to include both the nameplate charge and the calculated adjustments for the line set as well as the indoor coil.
The weigh-in procedure shall be performed in accordance with all manufacturer specifications to confirm that 1. The liquid line filter dryer has been installed, if required, per the outdoor condensing unit manufacturer's instructions, and it's installed with the proper orientation with respect to the refrigerant flow, if applicable. So this is the same requirement as we previously discussed in the standard charge procedure. So next we'll want to make sure that the system is brazed with dry nitrogen in the lines and the indoor coil, and then the system will be evacuated to 500 microns or less, and when isolated will rise no more than 300 microns over 5 minutes. So this is to limit the amount of moisture that's in the system, both with the dry nitrogen, and then as you draw that nitrogen out and you create a vacuum on the system, the moisture will come out as well with that, so that that filter dryer doesn't have to work as hard to get any remaining moisture out of that system. The line set correction is calculated based on the length and diameter of the line set. The indoor coil correction to refrigerant weight is used if it is supplied by the manufacturer. And last, the amount of charge calculated for the line set correction, which includes the indoor coil correction if available, is added or removed, or the total charge based on the line set, indoor coil, and standard label charge is installed.
The HVAC installer shall certify on the certificate of installation that the manufacturer specifications for these procedures have been met.
Now, as the HERS rater, you do have the option to observe this weigh-in charge procedure. Again, you're not going to perform the weigh-in charge procedure, but you will observe the installing contractor weigh in the charge. So now you're allowed to do this when the standards indicate that the procedure is required or is an option for compliance. So you will need to coordinate with the installer to be on site and observe the weigh-in charging procedure. You can do this if the temperature at the time of charging is less than 55 degrees Fahrenheit. The other option in those lower temperatures is possibly the winter charge verification procedure. Again, this is only applicable to equipment that is approved for that winter charge. If it's not approved for that, below 55, your only option is to observe the weigh-in. The second option is if the temperature at the time of your charging is above, equal to, or greater than 55 degrees, then you must use the standard charge verification procedure. The other option is if it was weighed in at a time when it was less than 55 degrees, the HERS rater can come back at a later date when the temperature does get into the range for the standard charge procedure and perform that standard charge verification procedure. So there's a couple of options, but the main thing to know is that if it's less than 55 at the time of charging, you'll likely want to be on site and observe that weigh-in charge procedure. If not, you'll have to come back later when it is within the range for the standard and then perform that standard charge verification procedure.
So when the HERS rater is actually verifying the weigh-in charge, the HERS rater shall observe and confirm that the system is evacuated to 500 microns or less, and when isolated, rises no more than 300 microns over 5 minutes. That the line set correction is calculated based on the length and diameter of the line set. That the indoor coil correction to refrigerant weight is used if it is supplied by the manufacturer. That the installer adds or removes the amount of charge calculated for the line set correction or installs the total charge based on the line set, indoor coil, and standard label charge. And now we're going to be mentioning the forms used for these tests. The CF3R MEC 25 Alpha is used for the standard refrigerant charge verification superheat method. The CF3R MEC 25 Bravo is used for standard refrigerant charge verification subcooling method. The CF3R MEC 25 Charlie is used for the weigh-in charging procedures HERS rater observation. So you're going to be using this form when observing the HVAC installer conducting the weigh-in charge. The CF3R MEC 25 Echo will be used for the refrigerant charge winter setup verification procedure. If you have any questions, feel free to give us a call, shoot us an email, or contact us through the LMS messaging system.